So zeros of a polynomial. Today we will see what are the zeros of a polynomial. Zeros of a polynomial is nothing but when we put the value that is satisfying the polynomial. For example, if px is a polynomial, x square plus 5x plus 6. Okay. And if you will put x is equal to minus 2, if we are putting suppose x is equal to minus 2 in this polynomial, minus 2, and find its value minus 2 square plus 5 into minus 2 plus 6 and solve it. Five into minus 2 plus 6. So this will become minus 2 square is 4, minus 5 to the 10 plus 6. 6 plus 4 is 10, 10 minus 10, 0. So we are getting answer 0. When we are getting answer 0, then we can say minus 2 is a 0 of the polynomial. The 0 of the polynomial px. So the value which will satisfy the polynomial is called the 0. So we can say 0 of a polynomial is a number such that 0 of a polynomial px is a number let's say C such that you put C in this polynomial, it will give you 0 such that PC is equal to 0. So this is the definition of 0 and this is the example I gave you. The example, you should write the example after definition. And now there are some important points that you have to remember regarding the zeros of polynomial. Important point that you have to remember. Number one, 0 may be the 0 of a polynomial. 0 value may be the 0 of the polynomial. 0 may be the 0 of the polynomial. For example, if px is a polynomial, 2x square plus x, then if you will put 0, x is equal to 0, you get 2 into 0 square 0, 0 plus 0 that is equal to 0. You get 0 answer. That means 0 is a polynomial. 0 is a therefore 0 is a 0 of this polynomial of this polynomial px is equal to 2x square plus x. So this is the first point. Number 0 can be the 0 of any polynomial. Can be. It is not necessary, it is always, but it can be. And every linear polynomial in one variable. Linear polynomial in one variable means linear means which has power only 1. Like I told you that what are linear polynomials? Linear polynomials can be written as linear polynomials are ax plus b in the form of ax plus b, standard form of linear polynomial. Okay, the power is 1. So every linear polynomial as the power is 1, so every linear polynomial, obviously it will have only one zero. So every linear polynomial in one variable. Generally we are having one variable, but here we should mention it. Because if it has two variables, then the case will be different. In one variable, linear polynomial in one variable has a unique zero, means only one zero. It has only one value. Has a unique zero of the polynomial. Zero of the polynomial. Unique zero of the polynomial. Okay, got it? Second point that you have to remember. Next point number 3 is a non-zero constant polynomial has no zero of the polynomial, that we have already seen. A non-zero constant polynomial means number, any number. Constant polynomial like 2, 3, 4, constant polynomial has no zero of the polynomial. Has no, a non-zero constant polynomial has no zero of a polynomial. No zero. Example, px is equal to 2. So 2 means x is to power 0. So it has no zero. We will not say that degree is different, but here we cannot put any value for 2. There is no x, so we cannot put, it has no zero. Okay. And the fourth point is every real number is a zero of the zero polynomial. Yes, zero polynomial. What is zero polynomial? Zero. Zero polynomial is what? Zero polynomial is 0. Px is equal to 0. When it is 0, it is a zero polynomial. Zero polynomial means to every real number. Whether we will put any number here, it is 0. So x can take any real number. X belongs to any real number. We used to write like this. In higher classes, just you try to understand this x will be a real number. So every real number, just remember this, every real number, every real number is a zero of is a zero of the zero polynomial. These are important points because in MCQs anything can be asked in MCQ of the zero polynomial. Although your MCQ will be based on a case study based, but this thing we will put in the case study and we can ask. So maximum number of zeros of a polynomial is equal to its degree. If a polynomial has 2 degree, it has 2 zero. If it has 3 degree, it will have 3 zeros. Okay. So maximum number of zeros will be, it can have same zero actually. Sometimes we have the same means equal zeros. So that time we have 1 0, but they are equal. So that's why we are saying that maximum number of zeros of a polynomial. Zeros of a polynomial is equal to its degree. Is equal to its degree. Means if a polynomial will have 2 degree, it will have 2 zeros. If it will have 3 degree, it will have 3 zeros. Like this one we can have. So I think you understood. Fine. We can take one question to understand more about the zeros, let's take one question. Find whether, if we have to find that whether it is a zero or not, so what we will do? Find whether, we will put and find out that it is, its value is zero or not. Whether -1 and 1 are the zeros of the polynomial, zeros of the polynomial, zeros of the polynomial x minus 1. Okay. Zeros of the polynomial x minus 1. So what we will do, we have given, we have given the polynomial dx as x minus 1. Okay. And we have to check x is equal to -1 and x is equal to 1. Both we have to check. Okay. Okay, got it? Run, do not disturb. Just listen whatever I am teaching you. So put x is equal to -1. X is equal to -1. So p x is equal to -1. -1 minus 1 will become -2, which is not equal to 0. So therefore -1 is not a zero, not a zero of px. Okay. And then we will put now x is equal to 1. X is equal to 1. So p1 will be equal to 1 minus 1. So we get 0. Therefore, x is equal to 1 is a zero of polynomial px is equal to x minus 1. So we have to just put the value and find out whether it is a 0 or not. But sometimes we'll take one more question. Sometimes you have to find the 0. How to find the 0? For example, question number 2. Find the 0 of the polynomial. Find, if simple polynomial is given, then find the 0 of the polynomial px is equal to 3x plus 1. So we will equate it to 0 and find the value of x. That will be the 0. So for this one, finding the 0, px should be equal to 0. So that is equal to 3x plus 1 is equal to 0. 3x is equal to -1, x is equal to -1/3. So simply equate to 0 and find the value of x. So x is equal to -3. If you will put, you will get 0. Therefore, x is equal to -1/3 is a 0 of the polynomial dx is equal to 3x plus 1. Okay. So whenever we have to find 0, we can find out like this. Exercise 2.1. Question number 1. Which of the following expressions are polynomials in one variable and which are not? State reason. Okay. So one variable and polynomial. It should be a polynomial and it should be in one variable. So question number 1 is px is equal to, we have given 4x square minus 3x plus 7. So we have to check power of x. Power of x is 2 and 1. So it is a polynomial and having only one variable x. So therefore, it is a polynomial. It is a polynomial of, it is a polynomial in one variable x. Second second. Just see that we have to just check the power. Here, most of you are getting confused when you are having the constant term as a root. Constant term can be root. This is a polynomial because the power of y is 2. So its degree is 2. It is a polynomial of one variable. It is also a polynomial of one variable. It is a polynomial in one variable y. Here it is given y. Before it was x, now it is y. Now check the third one. In the third one, you have given the variable in one. You have given the polynomial in one variable t. But whether it is a polynomial or not, we have to check under root t plus t root 2. Okay, here power of t is 1, but here what is the power of t here? Root means t raised to power 1 by 2, which is not acceptable for polynomial. That means it is not a polynomial. So when the power is 1 by 2 and fraction power, therefore root should be, if root is in the variable, then it is not a polynomial. If root is in on the constant term, it can be a polynomial. So therefore, it is not a polynomial. It is not a polynomial. Then there is no question. If it is not a polynomial, no question of the variable. It is not a polynomial. Okay. And the fourth one, yes, fourth one you have to check always. And the fourth one you have given py or qy, or you can denote by ry, but it should not be written. Polynomial should not be written in the numerator and denominator in the fraction. So we have to bring it in the numerator, power of y. What is the power of y here? When you bring it up, the y will get the power minus 1. So as I told you, y should have the power from 0 to any number, whole numbers, 0, 1, 2, 3, whole numbers. So I should have the power of whole numbers. Here my negative 1 is not a whole number, therefore it is not a polynomial. It is not a poly. Okay. And if you see fifth one is having three variables, x, y, and t. We will write like this: x, y, and t, and x raised to power 10 plus y raised to power 3 plus t raised to power 50. It is a polynomial, but it is a polynomial of three variables, not one variable. It is a polynomial in three variables. So it is a polynomial because powers are whole numbers, so it is a polynomial but in three variables. Polynomial in three variables. In three variables, x, y, and t. Okay, understood? Question number 2. Write the coefficients of x square. Write the coefficients of x square in the following given polynomials. So the first polynomial is px is equal to, first one is, we can write px is equal to 2 plus x square plus x. So what is the coefficient of x square? The coefficient is a number which is coming before x. Here before x there is no number, that means 1. We can write 1x square plus x. So therefore we can say the coefficient of x square in px polynomial this is equal to 1. So like this we have to find out. Second question, we have given px is equal to, we have given px is equal to Yes, we studied in class 8 also. 2 minus x square plus x cube. Correct? So before x square, we have to find the coefficient of x square is minus 1. Here we have given this minus 1x square plus x raised to power 3. So therefore, coefficient of f x square, this polynomial, is equal to minus 1. Similarly, third one is, we can denote by qx also. Qx is equal to pi by 2x square, pi by 2x square, pi by 2x square plus x. So before x square, the number is coming before x square is pi by 2. Therefore, the coefficient of x square is coefficient of x square in this polynomial qx is equal to pi by 2. So it's very simple. Here there is no coefficient. What will you write here? You have given this star x is equal to, let's do 2x minus 1. So there is no x square. So coefficient will be 0, because you can write 0 into x square plus root 2 into x minus 1. So 0. So therefore, coefficient of, when there is no term of x square, then coefficient will be 0. So coefficient of x square in this polynomial Rx will be equal to 0. So like this, we can find the coefficient of other terms also. X cube. What is the coefficient of x cube? 1. Constant term is 2. Here coefficient of x is 1. Constant term is 2. Here the coefficient of x is 2. Okay. So they can ask the coefficient of x also. Got it? Give one example each of a binomial of degree 35. Now see, we have to give the example of a binomial of degree 35. We can give many examples. So first of all, it is a binomial. That means it has two terms only, not less than or more than two terms. Two term binomial means two terms. So we can write two terms. And the highest power, degree is 35, means the highest power should be 35. Lowest power we can write anyone, but highest power should be 35. Okay. So how we will write? We can give many examples like dx is equal to 2x raised to power 3x raised to power 35, and then we can write any constant term. This is the binomial of degree 35. We can write other also, any one example. R y is equal to x raised to power 34. Sorry, y. Here this y value. Y raised to power 34 plus y raised to power 35. This is also a binomial of degree 35. Like this, we can give many examples. And monomial of degree 100. Monomial means only one term. Monomial means it has one term polynomial plus degree should be 100. Means power of x should be 100. So we can give many examples. Dx is equal to, simple example, x raised to power 100. It is a monomial. It has one degree and it has one term and degree 100. Like this, you can give many examples. Qy is equal to 5x raised to power. So make one term and highest degree is 100. So like this, we can write more examples also. They asked one example.